we're going to go and try to understand what does it mean to be a vertical asymptote, how are they formed, and why they are formed the way they are, right? And so trying to make sense of this can be extremely challenging, but we're going to do the best to make sense of it. So basically this idea comes about, right? Let's say we have this equation, y is equal to 1 over x. All right, and we have a very simple rational equation here, y equals 1 over x. All right, and the big question is, right, so if we try to graph this, now, the big question is, what happens if we try to plug in 0, right? So what happens if we try to plug in 0? Well, this is a problem because we can't divide by 0, all right? And the reason why, all right, well, let's kind of look at an example, right? 10 divided by 5 equals 2. All right, well, because 2 times 5 gives me 10, right? 10 divided by 5 is 2 because 2 times 5 gives me 10. So if we try using that logic, 10 divided by 0 equals, let's say this is possible, let's say it's some number, then this would say this number times 0 should give me 10. All right, just like over here, right? 2 times the 5. So 2 times the 5 should give me 10. Well, over here, this number times 0 should give me 10, and that's a problem because anything times 0 is just 0, which is not possible. So this is why we can't ever divide by 0, right? This is undefined. There's no possible way for us to figure out how to basically divide by 0, and we use the same logic up here. It's not possible, right? 0 times some number will never give you 10 because 0 times anything is always 0. All right, so because we're with this dilemma and we have this problem, right? We can't divide by 0. And so the question becomes, well, what happens if we get really close to 0? All right, so let me go ahead and start it fresh over here. So let's say we have our equation y is equal to 1 over x, okay? Well, the question becomes, what happens if we get really close to 0? We know we can't ever divide by 0. We already did that, but what if we try getting really close to it? Well, let's try using an example like this, right? Let's say we have $4, all right? And I'm asking you this question, okay? If I have $4, so let's just say the symbol S is $4. How many quarters do I have if I have $4, right? Well, there's 4 quarters in $1, so $4, I'd have 16 quarters, right? So this has to be 16. Well, what if I have 4 divided by 10 cents? Well, how many 10 cents are in $4, right? Well, there's 10 dimes. How many 10 dimes gives me $1. Therefore, $4 has to give me 40 dimes. So this is 40. Okay. Well, let's just go all the way down now to just 0.1. All right, 0.01. How many pennies are there in $4? Well, that's 400. So you could see, all right, if we keep dividing by a smaller number, our y values keep getting bigger, bigger, and bigger. And the reason why that is because we're essentially asking ourselves, right, here there's how many pennies are in $4? There's way more pennies because it's a smaller amount in a $4, 400 pennies. Whereas over here, right, there's only quarters, is already 0.25, so there's only going to be basically 16 quarters to give you $4. So you could see that the closer we divide by 0, the bigger our y values are going to get. All right, and so now if we actually try graphing this, we have y equals 1 over x. Okay, and we actually tried graphing this function. There we go. All right, if we actually try to graph our function, let's see what happens. We know it's at 0, it's undefined, right? We can't divide by 0. But what if we get really close to it? So let's try plugging in numbers that are really, really small, all right? And let's see what happens. Let's say we try plugging in negative 0.001, then we'll do negative 0.01 and negative we'll say 0.1. Over here we'll do the same thing, 0.001, 0.01, and 0.1. All right, and now let's see what happens, right? So let's take it and actually do it. We'll do some work over here. 1 divided by 0.1. Alright, so if we do 1 divided by 0.1, let's see exactly what that's going to get us. And essentially it's just going to be 10. So we'll go over here. Alright, and we're going to get 10. Which means up here we're going to get the same thing except negative 10. Okay, well let's go ahead and divide by 0.01. So let's do that. 1 divided by 0.01, and that's going to give me 100. I'm going to get 100, and over here, same thing, except it's going to be negative 100. And last but not least, what if we divide by 0.001, right? And you can kind of maybe see the pattern here, that we are going to get 1,000. And so you could see, just like I mentioned before with the other example, the smaller amounts that we divide by, the bigger our y values are going to get. And so over here is going to be negative 1,000. Okay, so if we try graphing this, let's say this is 0.1, right? We have 0.01, and now we're getting really close to 0.001. And then the same thing over here. Okay, well, what that means is that, well, okay, let's go ahead, let's go ahead and graph this function. Okay, so at 0.1 it's at 10, so it's somewhere over here. At 0.01 it's at 100, which is somewhere, let's say right here. And then at 0.001 it's all the way up to 1,000. Over here. And we can see the same thing over here, right? When it's at 0.1 it's all the way to 1,000. When it's at 0.01, you know, it's at, we said it was at 100, and then over here it was at 10, right? So you could see that our function is going to behave something like this. This is just going to continue to go up. And this is going to continue to go down. Okay? So you can see this is how our function is starting to look like. The closer that we get to dividing by 0, right, our y values keep shooting up. And you can see right here, this is how a vertical asymptote is formed. Essentially, our function, when we get closer and closer to 0 on the bottom, our y values go up and create this kind of vertical line right here. Right, essentially it's starting to approach this vertical line, which gives it this vertical asymptote. All right, so essentially anytime we find out where we get a 0 at, anytime we get really close by it, our y values are going to shoot up or going to shoot down, right? And so it's creating this kind of vertical line. So if we take that logic, right, and let's just go ahead and apply it to maybe something like this right here. Let's say y is equal to 1 over x plus 2. And the question is, all right, well, what is the vertical asymptote, right? We want to figure out exactly where does my function kind of do something like this, where it goes like that, and it kind of comes down like this, and it's creating this vertical asymptote line, right? It seems to approach that line. It's never going to touch it because we can't ever divide by 0. So if we want to find the vertical asymptote, well, we just focus on the denominator, right? What number do I need to plug in here so that this whole thing becomes 0? Well, I'll just actually solve for it. 0 is equal to x plus 2. We'll subtract 2 to both sides, and we're going to get that x is equal to negative 2. So that means that negative 2 is where my function should have a vertical asymptote. All right, so that means we can't plug in negative 2 because it's going to give me 0. So I can kind of create my vertical asymptote. It's going to be on this line right here. Okay, and as we get really close to negative 2, we're essentially going to be getting really close to dividing by 0 on the bottom here, closer and closer, which, as you saw before, our y values are going to get really huge. So, all right, our function is going to look something like this right here. And like that. You can see that's exactly where the vertical asymptote is being formed. All right. So this is exactly why it makes sense to kind of have vertical asymptotes and how it kind of forms. It has to do with this idea of what happens to our y values as we get really, really close to 0, right? And so we saw the example problem up here and kind of what we were working at over here, that as you divide at the closer and closer that you divide by 0, our y values keep getting bigger, which is the reason why if it makes this kind of shape right here where this goes down, this kind of goes up, and then it creates this vertical asymptote. All right, that's what it's called, to be a vertical asymptote. It's this basically this, right? Where it's the line that our function does not touch, but it's approaching to. So hopefully this video is just making sense, right? How exactly do we find vertical asymptotes, right? Well, we're going to set the denominator equal to 0 and solve, because that is where our function is going to create these kind of vertical lines and approach this vertical line that's never going to touch. So taking that idea, let's go ahead and maybe apply ourselves, all right, to making sense of it with maybe something a little more challenging. So let's say now we have y is equal to x minus 1, x plus 3, x minus 8, all divided by x minus 3 and x plus 4. And this problem is asking us, find your x-intercepts. And over here it's saying, find your vertical asymptotes. So this is applying what stuff we learned from the last video and putting it to good use here. All right, so if we want to kind of try to figure this out, well, first, to find the vertical asymptote, since we're on this video, we're trying to figure out what numbers do we need to plug in here to get 0 on the bottom, right? Because that's where our function will create that vertical asymptote, that line that's undefined. So we just set the bottom equal to 0, right? We have x minus 3 and x plus 4. And so we're going to set them individually equal to 0, x minus 3, and 0 is equal to x plus 4. We just add 3 to both sides now, and we're going to get x is equal to 3. We're going to subtract 4 to both sides, and we're going to get x is equal to negative 4. Okay, over here are x-intercepts. So again, we just focus on the numerator. So we're going to get 0 is equal to x minus 1. Oops. Okay, put some parentheses around there. X plus 3 and x minus 8. And we just focus on the numerator, right? We don't need to focus on the bottom. And we just say each one individually equal to 0. It's equal to x minus 8. And we add 1 to both sides. And we're going to get x is equal to 1. We subtract 3 to both sides, and we're going to get x is equal to negative 3. And we're going to add 8 to both sides, and we're going to get that x is equal to 8. And there it is, a problem like that, we're able to identify our vertical and our x-intercepts, all right? Hopefully that's helpful.